Okay, let's talk about material handling. And mainly when you think of material handling, a lot of times people think about forklifts and things like that. But we're going to talk about manual and then also machine material handling, and then a little bit about storage as well. Okay, obviously, material handling involves a whole different type of operations. Not only is it manual material handling, which is carrying bags or materials and unpacking materials, the physical part of it with a person, but there's also material handling via machine. Now, this can be a lot of different things: forklift, crane, any type of rigging, anything like that. And then the last part of it is actually stacking or storing. And this could be how you put all the boxes together, barrels, any type of lumber, bricks, any other material that we're talking about here. Now, manual material handling, there's a lot of information out there about that on proper lifting and things like that, making sure that the signage is there. There is this NIOSH ergonomic guide for manual material handling that's pretty diverse. And so, if your company is needing to make a manual material handling program, this would be a really good start and not trying to have to recreate the wheel. So when we think about manual material handling, once again, think of the physical aspect of it, of a person actually pushing, pulling, lifting, lowering, raising, anything like that. And that's what manual material handling is. So most injuries that occur from manual material handling have to do with back injuries. And there's several back injuries. It makes up about 20% of occupational illnesses when you look at the recording of this. And what normally happens is people trying to carry too much, possibly they actually have too much in their hands. They either fall, they end up being crushed by something falling on top of them. And the reason why we're really worried about this manual material handling and the injuries that occur because of this is because it does cost quite a bit of money. Now, a back injury is going to cost a lot of money for a company, but then also too, when you look at how long it takes for a person to return to work after, a major back injury, it's about 6 months. And after 6 months, only about 50% of employees actually return to work. And then after 1 year, only 25% return to work. So once again, you can see where we integrate like a return to work program in trying to get the people back to work. If not, you're going to lose some employees. And as I said, it's a very, very expensive injury when it comes to it. So some of the material handling hazards that we need to look at improper lifting, or maybe carrying things that are too heavy or awkward or too large for one person to carry. Then also too being struck by materials or somehow being caught in pinch points. And this is like two pieces of something coming together and it actually pinches someone. And it can be your hand, it could be, just about anything, your arm. And then also to crushed by machines. And this is where you start getting a little bit into forklifts, but people, these are material handlers, and something happens where maybe someone's struck by a forklift, which could be a major, major issue. Also, to incorrectly cutting ties and those bands that go around any type of, um, you know, material to secure it so that it doesn't move. A lot of times people are cut with that as well. And so there's a lot of hazards with regard to material handling. Now, when we start looking at it, and this is a pretty good chart that I found, and typically in my other classes, I have the people stand up and we talk a little bit about this. So you're just going to have to visualize, or you can do this since you're by yourself, hopefully. But when you start looking at it, if you have to lift something, you have a normal work zone, and this is going to be your waist to your shoulder. And in that zone, especially when it's close to your body, you can lift pretty much the most that you can, because this is going to be your normal work zone. When you start looking at getting out a little bit further, and this is like within, somewhat of an arm's reach or, a shoulder reach, that is going to be where you start lifting less. And the further you get out, and the higher up or the higher down you get out, where having to reach for things, the average person doesn't lift as much. So you can see here the near when you're just like really close to your body. you can lift quite a bit, and then as you start getting out 7 inches and 12 inches, it goes down quite a bit, especially when you're having to do it above the shoulder or below the knee. Now think about when you lift a large table or something like that. Typically, you're going to pull it to your waist, and you're going to make sure that it's really close to your body so that you can have some leverage against that. And as you can see here, that's about 90 pounds. And then your waist to your shoulder is going to be 70 pounds as well as below the knee. But as you start getting up and above your shoulders, you can't lift as much, and people don't tend to realize that. So when we start talking about the amount of force that's on the lower back, and I couldn't find a really good aim on this or a really good picture of this. When you're standing just upright, you have about 80 pounds, and this is an average person, about 80 pounds of weight or compression on your lower back. Now, if you actually pick up something that only weighs about 20 pounds, and you have it 10 inches away from your lower back, so you're holding it out 10 inches, which is about the length of your arms. If you have your shoulders bent at a 90 degrees and you're holding something that's 20 pounds, it ends up being 170 pounds of compression. And then if you lift it out further, let's say that you reach out and you're lifting it out where your arms are straight or pretty much straight, it's going to be 20 inches or so, and that 20 pounds of weight actually has about 260 pounds of force on your back. Now when you bend over, this is where your center of gravity is off. And so if you're at 20 inches with a 20-pound piece of something, it's going to have a compressive force of 635. And then if you have even just 1 pound, it's 460 pounds of compressive force. So you can see how that's really a big difference. Even just setting and leaning forward and lifting 1 pound, it's 220 pounds of compressive force. So this is how people get injured, even though they might not be carrying something that's very large or very heavy, because of the amount of force that's on that person. Now, all of these take into account a normal weight, which I'm not sure exactly what that is nowadays. But, the heavier you are, maybe if you're top heavy compared to being more of your weight in your lower half, obviously that factors into it, and the compressive force then would be greater if you were top heavy. Now, when you start looking at things to talk to employees about with regard to manual handling, obviously you want them to make sure that they have the proper grip on something and that they're able to lift it. So if it's too bulky, if it's awkward, something like that, we need to look and see what we can do differently. When you can't see around the load, this is where a lot of the issues come from. Maybe it's too long or wide. You can't see up over it. People end up not knowing where they're walking, and they trip and fall. When you can't handle some type of load safely, typically what happens is it falls down. And depending on what's in the boxes or containers that you're actually carrying, obviously it's going to be some type of issue. What we found, and this is something that we actually found at Blitz, that we were having people carry boxes, and they didn't even have handles in them. And at one point, they actually had a picnic table. It was probably a 3-foot by 3-foot box, and it was probably 12 inches wide. And inside this, they made the pieces that you actually would hook together 2x4s in, and it would make a picnic table, kind of an instantaneous picnic table, because everybody could take 2x4s, put screws in them, and then voila, you have this wonderful picnic table to enjoy outside. Well, what was very interesting, because we walked in there and they had this nice box, and the thing was in there, and it weighed probably about 30, 35, 40 pounds. And one of the things that I noticed right off the bat is it didn't have any handles. And so my suggestion to them was, hey, you know what? If I were a person and a consumer and I was looking for something like this, and one of the boxes had handles versus another box not having handles, I would probably pay a little bit extra for the box that has handles, mainly because it's going to be easier to load and unload. If you think about sticking it into a cart or something, obviously it's going to be a lot easier. You can see Target has done this as well. If you go in and you get a big bulk of toilet paper, typically what they'll have is, obviously you're not trying to carry it around in the big bulky thing, they put these little lift pieces of tape on it, and it's a lot easier for people to lift, which then again makes consumers happy. And then people who have to lift this all the time obviously would be happier too. So there is a couple of books out there when you start looking at it. The first one is the Revised NIOSH Lifting Equation, and in ergonomics, it's a class that I'm actually teaching next semester. We go quite a bit into material handling or ergonomics, and gets into the NIOSH Lifting Equation applications. And so you try to figure out how much is from here to here for an average person, and how much is here, meaning here to here, meaning elbow to wrist, and maybe wrist to tips of fingers, and all of us are made up differently. So how do you make this, straight across the board where everybody can do something properly? Well, the first thing you do is you need to have training. And a lot of times people, when they just bend right over. And so showing them how to lift things safely and properly will definitely, cause less stress on your body, and obviously then you won't be strained. And so what you also need to do is talk to them about the proper use of equipment, and then seeing how that they can see if there's any type of correction or prevention with regard to any potential hazards. So let's go through our engineering controls here first. Obviously, it's the first one, and as we've discussed previously, it takes the hazard out of the equation, and so the employee never even is up to the actual hazard itself. They never see the hazard. So let's look at workstation design. And when you start looking at this, and typically I'll have some examples, and we'll draw on the board, or we'll have something, but a person can change just something very, very simply and make things a little bit more convenient for them. If you have people that are reaching all the time, if you have people who are lifting things up and around and all of this stuff, it does cause some strain and stress. So just using like a conveyor or something like a U-shaped workstation where the person has everything just right there does make it quite a bit easier. Any type of lifting systems like hoists or vacuum lifts or any type of articulating arms, all of those fall into play, and it does cause less stress on the employee and the employee's body. Sometimes you will have to go with any type of redesign, whether it's any type of carts, or maybe making them higher, or any type of equipment. But a lot of times that is something that's a little bit more expensive. But companies do need to look at that and see what would be easiest for the employee. When you start looking at administrative controls, and this is the second level, so if you can't achieve it through engineering controls, you move on to administrative controls. And this is where you can actually give people a break, whether it's through job rotation. This employee only works for 2 hours, and then another employee comes back and works for 2 hours, and you rotate that job out actually. Or it can be simplistic as rest breaks, giving people time to rest in between the hard manual labor. And then, of course, training would fall up underneath here, too. Also, too, training them how to use material handling aids properly, and what the procedures are to that, and then making sure that the equipment is positioned properly so it does help someone versus hinder what they're trying to do. And then, as I said previously, training. It takes about 21 days for someone to develop a new habit. And so, going over it again and again and making sure that you're walking around and positively reinforcing it will definitely help the employees remember and continue to do it. So then the last thing is personal protective equipment, or PPE. And one of the things that you can actually do is gloves. Obviously some of the gloves have some grips on them, and it makes things easier to handle. You see leather gloves quite often, or neoprene gloves, not neoprene, I'm sorry, Kevlar gloves with regard to sharp edges, so that people aren't getting cut, and those will help out as well. Shoes, when you start looking at shoes, obviously steel-toed boots will help from anything dropping on them. Metatarsal guards will help the foot and try to keep that intact, as well as slip-resistant shoes as well. Now, the next part is material handling via machine, and this can be just about anything. It could be, an overhead crane, it could be a jib crane, it could be, forklift, whatever. But this is what we're going to talk about next. So, what you need to do is make sure that you actually know what the limitations of the equipment before you start operating it. And as you can see here, this is not a practice that I would definitely suggest. You can see that their forklift wouldn't go up as high as they wanted to, so they decided that they were going to go ahead and lift whatever this piece of machinery is on top of one forklift, and then they were going to have another forklift lift up this forklift. Now, I don't know if can you see any issues with this? I sure can, but obviously it seems to be working for them, but that's a risk that most people aren't willing to take. So you do need to make sure that when people use the equipment, that they use it properly and effectively. And as I said, this could be forks, cranes, scissor lifts, anything that has to do with material handling equipment. Now, forklift accidents, when you start looking at them, OSHA in 1977, and this is obviously a little bit dated, but it's the last statistic I could have found, that there was over 650,000 forklift accidents per year. And so when you look at this, 90,000 of these employees that were operating these suffered some type of injury. And this can also be something when you look at it, obviously they're going to have some type of physical suffering, but the mental suffering too with all the pain is going to be costly to the company as well as to the employee. So you look at the 90,000 employees that were injured, and there were 100 deaths out of that 680,000. If you look at what actually causes lift truck accidents, the main one is going to be a tip over of a forklift. And essentially, what a tip over is, if any of you have ever driven a forklift, is that the center of gravity on that forklift has been compromised in one shape or form. And this would be lifting something that's too heavy for the forklift, maybe lifting something up that's too high and then losing the balance on that. But that's the one that actually makes up the most percentage. The next one is going to be struck by a powered forklift, and this would be someone walking or someone doing something like that, and an arm swings around and actually hits them. And then struck by a falling load. This could be the operator or it could be someone else on the forklift. It doesn't specify here. And then actually lifting someone up on a forklift on the lift part of it. You can see quite a bit of percentage, and then running off the dock is actually pretty a serious accident, and it accounts for 7% of that. So when you do have a forklift, it's kind of like driving a car, but your load is normally in front of you, and a lot of times you can't see around that load. Several forklift operators and companies that I've seen also too drive backwards because the load's on the front and you can drive backwards. So you have to, have look out for a lot of pedestrians that are walking by. And for some strange reason, a lot of times employees think that the forklift needs to get out of the way of them, which is kind of silly. A forklift actually weighs more than a pickup truck, and so when someone is driving that, they obviously have major blind spots and they would be carrying a load. So you might have an over 5,000 K forklift that has a load on it, and it's not going to stop very quickly. And so you really need to make sure that you're training employees or pedestrians that are around these forklifts to actually watch out for them, as well as the forklift drivers watching out for the pedestrians. Obviously, blind spots. Or an issue. It's kind of, if you liken it to a car, if you haven't driven a forklift, but there's tons of blind spots on a forklift. Driving indoors and outdoors and just having to change your eyes and weather conditions, things like that, those always cause some issues. Narrow aisles, and you'll see a video at the very end where some narrow aisles really caught some people in some compromised positions. Aisle intersection is this is where two intersections meet. I've seen two forklifts run into each other. I've seen people walk out in the intersection and people get hit in those intersections. So having some type of policy where the person slows down and honks their horn is not going to help productivity, but it will obviously help some potential problems with regard to intersections. Building columns, these were always hit. We would have accidents or we call them a forklift accident category 1, when we would find that a building column had been hit, and we had these protectors that are around them that would help out. But a lot of companies don't have that, and I think in one of those videos it shows you a building, a column or to racking system that's actually compromised, and it causes something to fall down. Also, too, forklifts, they operate 24 hours a day, and there's not a lot of rest for them or the people that actually operate them, and so there's a lot of wear and tear with regard to forklifts. And then if you've ever been in a forklift, it turns differently than a regular vehicle. Typically, you'll have your front wheel drives and on your actual car or vehicle, and it'll turn that direction. But a forklift has a turning radius, and it can just spin around in a circle or a very small circle. But you do have to make sure that everything around the area is clear on that turning radius. When you start looking at pedestrians, they do contribute to a lot of accidents because they don't understand, and I'd mentioned that previously about stopping, and they try to beat the truck. It's kind of like you trying to walk out in front of Walmart, at your local Walmart store, and trying to beat the car that's not slowing down or something like that. And this does cause for quite a bit of accidents in the workplace. So, how do you actually reduce forklift accidents? The first one's going to be training of drivers, making sure that they understand exactly what the operation of the vehicle is and some of these factors. The next one is going to obviously be maintaining that equipment and making sure that it's in proper working condition, and that the brakes and the tires and everything else are working properly, as well as the lights, horns, and everything else. And then the last thing is to designate specific areas of operation, because at that point the employees will know exactly where they are to operate and where they are not to operate. So with powered industrial truck training, there's a lot of things that you go through. Obviously, you're going to talk to them specifically about the forklift, and then also the workplace, and making sure they understand those topics related to both of those. There are standard requirements with regard to industrial truck or powered industrial truck or forklift training. Trainees must be actually taught by a competent person, and you do have some formal instruction where you're normally going to be sitting in a classroom getting face-to-face time, and then some practical training where you go out and actually try to drive the forklift itself. And then someone will evaluate you, and they need to evaluate you obviously in the formal instruction and the practical training. Now, this is something that really needs to be documented, and you need to make sure that you're keeping track of this. OSHA has a 2-year requirement on this, and so that, or excuse me, 3-year, and so every 3 years you have to retrain employees on powered industrial trucks, and they will come in and ask you for the training records to make sure that's correct. Also, too, the powered industrial truck or the forklift license needs to be on the employee at all times, especially if they're operating the vehicle, because if OSHA does come in, they'll ask to see their driver's license or their license with regard to training on the vehicle. So there's a lot of other different types of PIE, and those are powered industrial equipment, and that's how OSHA actually refers to it. The first one on the left you can see is a scissor lift, and it's called a scissor obviously because it looks somewhat like a scissor. And this will lift you up and down. There's no extension on this. It's merely going to be straight up, straight down. And there's specific requirements on the scissor lift on that. The other two are different types of aerial booms. One is kind of a cherry picker, and one is more of an aerial truck or aerial boom, however you want to call it. And then tractors would also fall under other PIE. Another thing that would fall under that is cranes, and this can be like an overhead crane, or it can be a gantry crane. Now the overhead crane is going to be, and typically I would draw this out, but I can't obviously, but it's going to be on some 4 poles, and it's going to roll back and forth, and so it can lift quite a bit of weight. Typically when put in, they're very costly to put in, and they do dig down deep and have piers that are dug to hold these cranes out because they do weigh so much. And plus too, you can lift quite a bit with those, but it's only in a very limited area. The other type of crane is a gantry crane, and it's something that you see on TV quite often, or you may see at construction sites that lift heavy objects. There's some that are portable, and then some that are going to be, built at the scene. And lately, you've seen quite a bit of accidents with regard to these cranes in work situations, especially construction, of them collapsing and causing, quite a bit of issues. Now, these are some of the things that you have to be trained to with regard to crane safety. Obviously, knowing how to assemble and disassemble the crane. Power line safety is very important, not just in crane safety, but it's going to be in any of your PIE, trying to train to that. Inspections with regard to any ropes or safety devices, any type of authority to stop operation. The signals, there's specific signals with crane safety, and fall protection, as well as trying to get your qualifications for your operators and your spotters and the certification that goes along with that. Typically, a company is going to have to hire someone to come in and do crane safety, and if that's something that you're interested in, it does pay quite a bit, and there's not that many around. It's hard to find those nowadays. The signal person, the qualifications on them are going to be a little bit more specific to their job, and these are some of those. And then the tower cranes, you can kind of see the gantry tower crane there, the derricks, floating cranes, all of those. All of them are going to have specific training, but obviously you can see that it's going to be pretty specific. The next thing I want to talk just a little bit about, I know we don't have a lot of time to get into this, but it's talking about chain wear. And when you start looking at the chains, they are pretty resilient and they actually last quite a bit. But a lot of times people don't look at any type of pitting or cracked, and so that's when it needs to be removed from service. And you can see on this, it's not on this chain here. It doesn't have a lot of smooth surfaces, and you can see that it has a little bit of rust on it. On this, you can see some pitting as well, and I'd probably go ahead and pull this from service because you can't repair it. The other thing that goes along with any of the PIE a lot of times is going to be wire rope slings, and these need to be removed from service if you can actually see any type of kinking or crushing or bird caging. Now, your bird caging is a picture of it here, and it's essentially where it has been extended and then it's been pushed back and it kind of untwists a little bit, and it causes some major issue and compromise. And you can see some of the wires are compromised there and cause some breakage. Definitely this needs to be pulled out of service as soon as possible. Your kinking is going to be something that's been overextended and then kind of goes back and it's going to kink up a little bit. A hose would do the same thing, like a water hose might do the same thing where it kinks up and it has some issues. And then any type of crushing to where you can see a visible difference in the width of the rope sling. Those are some things that you need to look out for with regard to that and remove them from service as soon as possible. Okay, other safety related material handling items to look at. Stacking and storing materials, and OSHA has pretty good information on material handling. As I told you previously, they have this on the construction side, but then you can use this. One of the things, and I think I've mentioned this previously, is that not only do you just always fall under general industry, a lot of times you'll dip into other OSHA regulations, and this would be one of them where you would, because it talks about construction safety in this. But you can also find information in the general industry as well. So storing materials, you do have to make sure that everything is secure. If you're stacking, racking, blocking, any type of interlocking, to make sure that they're not going to fall on someone. This is where too you start getting into load limits of floors, and also is shelving here, which is not listed. And you can see the sign here where it says this floor will safely sustain a load of 100 pounds per square foot, and actually have an engineer or someone in your facility come through and look and say, how much is this going to be? When it's a floor, obviously, is one thing, but when you start looking at stacking things on shelving, it's going to be very important so that it doesn't become top heavy and fall over. The other thing is you need to have some housekeeping issues taken care of here, and that's keeping aisles and any type of passageways free and clear from any type of or any type of hazards that might be there. So get a little bit into fall protection, and I think Pat is going to talk about this. I believe he is. So I'm not going to talk too much about it, but really you're worried about a lot of different things, and a lot of times people will go get their fall protection, and it's kind of a general fall protection where anybody can use it, or sometimes you're assigned fall protection at your job, and this just isn't in construction. You do have to have fall protection on when you're in aerial lifts or scissor lifts or some type of thing like that. So when you start thinking about it, they go grab a fall protection gear, and employees they don't think about how fall that distance is. And so there's three or actually four different links when you start looking at it. If they actually free fall and it's going to be 6 foot, you think a person's 6 foot tall, and so you have to put that into the distance. The total distance of the fall is going to be how much ever it is from that height to the floor or to whatever's down below. Now what happens is they have the person's 6 foot tall. Maybe you've got a 6 foot fall protection, and what people don't add in there is that elongation. And so what will happen is that it actually elongates to kind of prevent the shock of the fall, and it does cause some issues because people don't put that in there, and they say, oh, well, I'm 6 foot off the ground, I'm going to use a 6 foot fall protection, which isn't going to help because they have that elongation in there. It's kind of easier to show when I'm face to face because I typically bring in fall protection so you can see what I'm talking about. Housekeeping, as I mentioned, is going to be a really big issue when having anything around forklifts or any type of other storage areas, or just people walking and trying to lift these things. Because if things start accumulating in certain areas, obviously trip hazards, you could have some fires, all of those types of things. Okay, so that's it for the material handling, and this is kind of an interesting video if you want to watch it. It's kind of funny. I would hate to be the employees that actually cause these issues, because I doubt very seriously they are employees of those companies any longer. So enjoy that, and I will talk to you later.